Imagine standing under a clear night sky, gazing up at a sea of twinkling stars. Each one seems so close, yet so impossibly far. You might wonder, just how far away is the nearest star? It's a question that has fascinated humans for centuries, sparking curiosity about our place in the cosmos. The answer takes us on a journey through the vastness of space, the wonders of astronomy, and the incredible scale of the universe. Let's embark on this exploration together, uncovering the facts, the science, and the awe-inspiring reality of the nearest star to our own sun. To begin, let's set the stage. Our sun, the star at the center of our solar system, is a blazing ball of plasma that provides the light and heat necessary for life on Earth. It's massive, with a diameter of about 1.4 million kilometers. Yet it's just one of billions of stars in our galaxy, the Milky Way. But beyond our sun, what's the closest star we can find? The answer lies in a stellar system called Alpha Centauri. It's a trio of stars that hold the title of being our closest cosmic neighbors. Alpha Centauri. It's not just one star, but a system of three. Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Proxima Centauri, the smallest and faintest of the three, is technically the closest star to our sun. It lies approximately 4.24 light-years away from Earth. Now, you might be thinking, what exactly is a light-year? A light-year is the distance that light travels in 1 year, moving at the incredible speed of about 300,000 kilometers per second. To put that into perspective, light from the sun takes about 8 minutes to reach Earth. But light from Proxima Centauri takes over 4 years to make that journey. That's a staggering distance. It's just the beginning of our story. Let's break down that distance to make it more relatable. 1 light year is roughly 9.46 trillion kilometers. So, Proxima Centauri, at 4.24 light years, is about 40 trillion kilometers away. If you were to drive a car at a constant speed of 100 kilometers per hour, it would take you roughly 460 million years to reach Proxima Centauri. It's longer than humans have existed as a species. Even our fastest spacecraft, like NASA's Voyager 1, which travels at about 61,000 kilometers per hour, would take over 73,000 years to get there. These numbers show just how vast the gap is between us and even our closest stellar neighbor now. Let's talk about Proxima Centauri itself. Discovered in 1915 by Scottish astronomer Robert Innes, Proxima Centauri is a red dwarf star, a type of star much smaller and cooler than our sun. It's about 1/8 the mass of the sun and only about 1.5 times the diameter of Jupiter. Because it's so faint, you can't see Proxima Centauri with the naked eye, even on the clearest of nights. It's located in the constellation Centaurus, visible primarily from the southern hemisphere. Despite its faintness, Proxima Centauri is an active star, known for producing powerful flares that can temporarily increase its brightness. These flares are bursts of energy, like solar flares on our sun, but they're much more intense relative to the star's size. Proxima Centauri's place in the Alpha Centauri system is fascinating. While it's the closest star to us, it's actually quite far from its siblings, Alpha Centauri A and B, which are about 4.37 light-years from Earth. Alpha Centauri A is a star very similar to our sun in size and brightness, while Alpha Centauri B is slightly smaller and cooler. Proxima Centauri orbits these two stars at a distance of about 0.2 light-years, or roughly 2 trillion kilometers. That's so far that it takes Proxima Centauri about 500,000 years to complete one orbit around the Alpha Centauri pair. This makes Proxima a loosely bound member of the system, almost like a distant cousin. Why does the distance to the nearest star matter? For one, it helps us understand the scale of the universe. The Milky Way galaxy is about 100,000 light-years across, so 4.24 light-years is just a tiny step in cosmic terms. But for humans, it's an enormous leap. The distance to Proxima Centauri represents a challenge for space exploration, a reminder of how difficult it is to travel beyond our solar system, yet it also inspires us to dream big, to imagine what might be out there waiting to be discovered. Let's dive deeper into how we know Proxima Centauri is the closest star. Astronomers use a method called parallax to measure the distance to stars. Imagine holding your thumb up and closing one eye. Then switching to the other eye. Your thumb appears to shift against the background. Stars do something similar when Earth moves around the Sun by observing a star from opposite sides of Earth's orbit. 6 months apart, astronomers can measure the tiny shift in the star's position against the background of more distant stars. This shift, called the parallax angle, allows scientists to calculate the star's distance using simple geometry. For Proxima Centauri, this parallax measurement confirms its distance of 4.24 light-years with remarkable precision. The history of measuring stellar distances is a story of human ingenuity. In the early 19th century, German astronomer Friedrich Bessel was the first to successfully measure the parallax of a star, 61 Cygni, in 1838. This breakthrough opened the door to understanding the true scale of the universe. For time, telescopes and instruments became more precise, allowing astronomers to measure the distances to closer stars like those in the Alpha Centauri system. Today, missions like the European Space Agency's Gaia spacecraft are mapping the positions and distances of billions of stars with unprecedented accuracy, giving us a clearer picture of our galactic neighborhood. Now, let's explore what makes Proxima Centauri so intriguing beyond its proximity. In 2016, astronomers announced the discovery of an exoplanet orbiting Proxima Centauri, named Proxima Centauri b. This planet is about 1.17 times the mass of Earth and orbits its star every 11.2 days at a distance of just 7.5 million kilometers. That's much closer than Earth is to the Sun. But because Proxima Centauri is so cool, this planet lies in the star's habitable zone, where liquid water could potentially exist. The discovery sparked excitement about the possibility of life. Beyond our solar system, could there be alien microbes or even more complex life forms on Proxima b? We don't know yet, but the idea is tantalizing. However, Proxima b faces challenges that make habitability uncertain. Proxima Centauri's frequent flares could bathe the planet in intense radiation, potentially stripping away its atmosphere or sterilizing its surface. Additionally, the planet is likely tidally locked, meaning one side always faces the star, creating extreme temperature differences between the day and night sides. Scientists are still studying Proxima b to understand its atmosphere, surface conditions, and potential for life. Future telescopes, like the James Webb Space Telescope, might help us learn more by analyzing the planet's light for signs of water vapor or other molecules. The Alpha Centauri system as a whole is a treasure trove for astronomers. Alpha Centauri A and B, being brighter and more sun-like, are also prime targets for exoplanet searches. In 2020, researchers detected a possible planet candidate around Alpha Centauri A, though it's still unconfirmed. These stars are close enough that we can study them in detail, offering insights into stellar evolution and planetary systems. For example, Alpha Centauri A's similarity to the Sun makes it a great case study for understanding our own stars' behavior over billions of years. Let's take a moment to consider the broader context of our place in the universe. The distance to Proxima Centauri, while vast, is just a tiny fraction of the Milky Way. Our galaxy contains an estimated 100 to 400 billion stars, many of which likely host planets. Beyond the Milky Way, there are trillions of galaxies each, with billions of stars. The nearest star reminds us that even our closest neighbors are incredibly distant. Yet they're part of a cosmic tapestry that stretches far beyond our imagination. This perspective humbles us, but it also fuels our curiosity to explore further now. Let's talk about the human dream of reaching the stars. Traveling to Proxima Centauri with current technology is impossible within a human lifetime. Our fastest spacecraft are far too slow, and the energy required to accelerate to even a fraction of the speed of light is immense. But scientists and engineers are dreaming up innovative solutions. One ambitious idea is the Breakthrough Starshot project, announced in 2016 by physicist Stephen Hawking and entrepreneur Yuri Milner. This project aims to send tiny, sail-like spacecraft to the Alpha Centauri system using powerful lasers to propel them to 20% of the speed of light. At that speed, the journey would take about 20 years, plus another 4 years for signals to return to Earth. Breakthrough Starshot faces huge challenges. The spacecraft, called nanocraft, would need to be incredibly small, about the size of a postage stamp, yet durable enough to survive the journey. It'd also need to carry cameras and instruments to collect data and send it back across 4.24 light-years. The lasers required to propel these nanocraft would need to generate enormous power, far beyond what we can produce today. Still, the project represents a bold vision for the future of interstellar exploration, showing how human ingenuity is pushing the boundaries of what's possible while we're dreaming of interstellar travel. Let's not forget the practical challenges of measuring and understanding distances in space. Beyond parallax, astronomers use other methods to gauge the distances to more distant stars. For example, they study the brightness of certain types of stars. It's called standard candles, like Cepheid variables or supernova. By comparing how bright these stars appear from Earth to how bright they actually are, scientists can estimate their distance. These methods build on the foundation of nearby stars like Proxima Centauri, whose distances are measured directly with parallax. The study of nearby stars also helps us understand the structure of our galaxy. The Milky Way is a barred spiral galaxy, with our Sun located about 27,000 light-years from its center. Proxima Centauri and the Alpha Centauri system are part of our local stellar neighborhood, a region that includes dozens of stars within about 15 light-years. Some of these, like Barnard's star, 5.96 light-years away, or Sirius, 8.6 light-years away, are also fascinating targets for study. Each star adds to our understanding of the diversity of stellar types, from massive, short-lived giants to small, long-lived red dwarfs like Proxima Centauri. Let's reflect on the cultural and philosophical impact of knowing the distance to the nearest star. For centuries, humans have looked to the stars for inspiration, guidance, and meaning. Ancient cultures created myths and constellations to make sense of the night sky. So the realization that even the closest star is so far away challenges our sense of scale and significance. It reminds us that we are a small part of a vast universe, yet our ability to measure and understand these distances shows the power of human curiosity and intellect. In science fiction, the idea of traveling to nearby stars is a common theme. Books, movies, and TV shows often imagine faster-than-light travel or wormholes that make interstellar journeys quick and easy. While these ideas are fun to explore, the reality is far more daunting. The distance to Proxima Centauri is a reminder that the universe doesn't bend to our wish, so challenges us to innovate, to think creatively, and to push the limits of technology. Let's also consider the role of Proxima Centauri in the search for extraterrestrial life. The discovery of Proxima b has made this star a focal point for astrobiology, the study of life beyond Earth. Scientists are eager to learn whether planets around red dwarfs, which are the most common type of star in the galaxy, could support life. Red dwarfs like Proxima Centauri make up about 75% of the stars in the Milky Way. So if their planets are habitable, the chances of life elsewhere increase dramatically. This makes Proxima Centauri not just a nearby star, but a key piece in the puzzle of life in the universe as we think about the future. It's worth noting how our understanding of the nearest star has evolved. Just a century ago, we didn't know Proxima Centauri existed, okay? We're finding planets around it and dreaming of sending spacecraft there. Advances in technology, like more powerful telescopes and space probes, are bringing us closer to answering big questions about our cosmic neighbors. For example, the upcoming extremely large telescope, set to begin operations in the late 2020s, will allow astronomers to study Proxima b in greater detail, potentially revealing clues about its atmosphere and surface. The journey to understand the nearest star also connects to our own story as a species. The desire to explore, to reach out into the unknown, is a fundamental part of who we are. From the first humans who navigated by the stars to modern astronomers mapping the galaxy, our curiosity about the cosmos drives us forward. The distance to Proxima Centauri, while immense, is a challenge that inspires us to keep learning, to keep exploring, then to keep dreaming. Let's take a step back and summarize what we've learned. The nearest star to our Sun is Proxima Centauri, located 4.24 light-years away, or about 40 trillion kilometers. It's a red dwarf star, part of the Alpha Centauri system, and home to at least one known exoplanet, Proxima b, which might lie in the habitable zone. Measuring this distance using parallax has given us a precise understanding of our closest neighbor, while projects like Breakthrough Starshot show our ambition to one day visit it. The vast distance to Proxima Centauri highlights the scale of the universe and challenges us to think bigger about our place in it. Why does this matter? Because knowing the distance to the nearest star isn't just about numbers, it's about perspective. It's about realizing how small we are in the grand scheme of things, yet how powerful our minds are in unraveling the mysteries of the cosmos. It's about the spark of curiosity that drives us to ask questions, to build telescopes, to launch spacecraft, and to imagine what lies beyond. Proxima Centauri, as our closest stellar neighbor, is a symbol of both the challenge and the wonder of exploring the universe. As we conclude, let's imagine standing under that night sky again. The stars above us are more than just points of light. They're destinations, mysteries, and possibilities. Proxima Centauri, 4.24 light-years away, is the closest of those possibilities. It reminds us that the universe is vast, but our capacity to explore it is boundless. So, the next time you look up at the stars, think about Proxima Centauri, our nearest neighbor, okay? And let it inspire you to keep asking questions, to keep exploring, and to keep reaching for the stars.